Okay, so I think it's time we can start. So how about I'll give a very high level introduction. I'll kind of introduce Andrey. Andrey, feel free to dive in at any point and correct, tell some more stuff about you. But this is the second webinar we're having about LLMOps.Space. A bit about like what LLMOps.Space is and about the session and so forth. So last time we started off with how to build a general LLMOps stack. Working with we had a couple of amazing folks from Databricks. In this session, we're going to start talking to one very specific aspect of it, about taking open source LLMs and leveraging them to actually use them for production. So in general, the events, we're not just going them for like maximum popularity and so forth. We're trying to build them in a way where each time we're touching a different angle, and we can really get into the point where if you go over everything that you feel like you learned something, it's meant, both for entry level, but also for people that are actually already practitioners and have built and worked with things for a while. So we'll be discussing all sorts of things that you'll see a few times in the agenda. And yeah, this, it was advertised. Feel free to introduce yourself, ask questions during the session, before the session, after the session, but whatever you do during the session, we might address like in real time, kind of like you might do sometimes with the regular questions on Zoom. So yeah, this is the link to the Discord, and that's where we're going to have it. And we're going to be talking in the general chat there. So about the LLMOps space, it's a global community for LLM practitioners. I mean, the focus, at least currently, is online. The idea is there are a lot of things that have to do with operationalizing AI or machine learning, but this is designated for LLMs. So if you're working with LLMs, then it's only with the content that's relevant for that. With anything that's related to deploying LLMs into production, more as like a builder, less as a user. And yeah, it's growing pretty quickly. And, we're going to have a few more and more interesting issues that are happening, including events that are designated, let's say, around a specific startup or company that wants to launch and so forth. Not everything is going to be of the exact same type. So we created this list of products and companies that we're going to continue to update. And the idea is, we think this ecosystem is going to grow a lot. It's not going to be static. And when you're building, you really want a lot of this digested and not to hear all the noise. And we're training the community to be, even as this grows, to have it organized, easy to find resources, events that focus on what's interesting for the community members and so forth. So a bit about the agenda for today, and here, Andrey, feel free to dive in. I know we did this, a while ago, but open source LLMs in a few different areas, fine-tuning quantization, cost considerations, and hosting economics and frameworks to use them. I'm sure there will be a lot of different, some of the focus might be less on these than some of the other ones, but these are the kind of things we thought of in advance. And a bit about the speakers. So I'm less of a speaker, I'm more of a host, but I'm managing the community here, and day-to-day I'm working with my team Dstack mainly on continuous validation, which means evaluating, monitoring, and so forth of LLMs and AI. And we have with us today Andrey from Dstack, which spends a lot of time on generative AI in many different areas, and previously worked at JetBrains across many different teams, including PyCharm. So those of you that are passionate about not using notebooks, and yes, PyCharm, so you have a role model here with us today. Anyone that wants to speak at future events, pretty easy to find. We created this short link, but you can also reach out on Discord. You will have to fill out the same kind of form eventually, just so we get the details, but you know different ways to start, and that's it. So I guess over to you, Andrey.
Awesome. Thank you, Philip. Sharing the screen now. Yep. Please confirm, Philip, that you can see it.
Yes.
Awesome. Yeah, excited to talk here. And maybe to add to the agenda that Philip shared. This is going to be, to a certain extent, introductory call, and And well, the sweet spot is like in terms of targeting there's a lot of people that are using LLM today through their proprietary services like LLM as a service, and quite a lot of people are also curious about alternatives. And thanks to their recent development in the open source community, there are a lot of open source LLMs, and there's a lot of people that are wondering like how they compare to proprietary services and what are their nuances of using them in production, how they can compare. And so there's a lot of questions, and by no means I aim to answer all of them or go into very to depth. So expect to hear, learn about the most notable open source models, about optimization techniques important for using these models in production, a bit on economics, and then also, if we have enough time, we'll cover some of the frameworks which are very useful. And if you are already an expert in open source LLMs, probably you're not going to hear anything new, but if you are about to learn about open source LLMs and would like to systemize these basic concepts and knowledge, I guess that would be a great fit. So having said that, the first thing we would like to maybe mention is what are the reasons for using open source LLMs in the end. Well, there could be many reasons, and I would like to mention 4 of them. First one is, and probably the most important, is customization. Open source LLMs are great because there are many LLMs, and you can take any of them, and if their license is permissive, you can build on top of that model. And it means that you don't depend on any proprietary thing. You build on top of open models, and you can customize one model, and then you can customize another model on top of their previously trained model, which allows you to create a lot of different specialized models, which is great. And we'll probably mention customization quite a few times through the slides.
Wait,
the second,
Andrey, just 1 second. I want to give a quick announcement. I know some people joined just now. The correspondence questions and so forth, we're not going to do it here in the Zoom. We're going to do it. I saw there are already a couple of questions. We're going to do it in the Discord. So we sent the link for the Discord for those of you that aren't there. It's going to be in the general chat channel. So I'll be taking questions from there, answering some of them in real time, giving some of them to Andrey. Anyway, back to you.
Awesome.
Okay.
Yeah. Looking forward to questions as well. I don't see the questions in like real time. But so yeah, please read these questions out loud, Philip, when you have a chance.
Yeah, I'm on.
And meanwhile, I'll just continue, but feel free to interrupt me at any point. Yeah. Well, the other 3 reasons worth mentioning. One is quality control. Imagine that you are building on top of, let's say, GPT-4 or GPT 3.5, and the model behavior is changing constantly to evolve a lot of policies, and it updates for their performance being improved at all. And if you depend on their model behavior in your business, and this behavior changes at any time, well, there is a big risk. That's why, for example, if you are using an open source model, then you have the full control over their model behavior. Then there is data privacy. I don't want to go into a lot of details in regard to data privacy. There are different views on that, and a lot of companies have different idea of what level of data privacy they want. But what is certain is that if you are using an open source model, you can host it according to your data privacy setting, and you have full control there. And finally, cost. When you are using an LLM as a service, such as ChatGPT, for example, you typically pay per token, and you are using very specific types of model, and most of the time these models are generalized models, and pricing is still the same. which means that there is not a lot of flexibility. And with open source, in the end, you can use many different models, and then cost depends greatly on the size of the model and how you use it. So there is a lot of flexibility. Another slide is a bit controversial.
I just want to jump in and say, in one of the bullets that you mentioned, which is the one of quality control, there was a lot of noise about OpenAI, potentially not changing GPT-4 in the backend. So it's like my feed was full of it. A lot of people asked me that. Did they, either to save costs or for whatever other reasons, did they change the model in the backend and so forth? So I mean, this might connect with some discussions you've been having in your living room. So of course, if you know exactly what's happening there, and only someone from your company can change to the next version, then that does help.
Yeah, some people don't even know that the model is actually changing its behavior. And if you go and see what are their recent versions, you basically going to see that even benchmark data changes day to day for GPT 3.5 and 4. So we'll probably also mention that when we talk about code generation, there is at least one example.
But also another note before we dive in, I don't think that Andrey is recommending, or I wouldn't recommend. And I think just talking to Andrey before, I don't think it means okay, so everyone should be using open source LLMs all the time, right? So now you're going to get some of the characteristics of when it's better, when it's less good, but of course, since both of these approaches are surviving, you can understand that it's probably not because half the people are dumb. But that there are different circumstances that in some cases it makes more sense or less sense to use these open source LLMs.
Yeah, there is lots of ways of hurting yourself, both ways, open source and proprietary ways. So everyone is welcome to try it and prove right. Awesome. The next one is I promised you to mention most notable open source releases. And again, bear with me. By no chance I can cover all important releases. It's just not possible. If you follow, you probably know that there is a new release pretty much every day, or sometimes several releases of very interesting models. But here, I'd like to mention a few, in my view, most important releases. And first in this list is Llama 2. And another reason for that is that probably most of you already heard about it. Some know, some wonder what's so special about Llama 2. There's lots of things to mention about Llama 2, but I would just limit it to the following. First of all, it's a model by Meta, done in partnership with Microsoft, available in 3 different sizes, like 7 billion parameters, 13 billion parameters, and 70 billion parameters. It's available in 2 versions. One is base model, which can be used for any sort of fine tuning, and another one is a chat version of the model, which means that it can be already used for chat conversations. It means that this model is aware of the chat format, and it is able to follow instructions, which means that it was fine-tuned on chat data. Then it's one of the models which has exceptional performance compared to other open source models, even now after several months since their release. Most importantly, the license is super permissive, means that you are free to use it for both research and commercially, with some exceptions, but they are so minor that you can just think of it as it's just free. Maybe last one, Llama 2 is mostly for English language. So if you are interested in other languages, then you would probably look into other variants. Second model in this list is Code Llama. It was released several months, one or 2 months following the release of Llama 2. It's also by Meta. What's so special about it? It inherits a lot, most of what I said about Llama 2, about like model sizes and like formats. Like there is a chat format, there is a base model. Also, basically what this model does, it completes code. It is able to generate code. So it means that it was fine-tuned on a lot of data, a lot of code data. It can not only generate code, but also can answer questions about the code. And also it supports this fill in the middle concept, which allows you to, for example, ask the LLM to insert code fragments into their given prompt. Also, there is a Python flavor. Basically means that it was fine-tuned on Python code, and it is better than the base model. And last one to mention about why Code Llama is so important. Just like Llama 2, this model has quite impressive performance, but just like Llama 2, it's very customizable. Means that you can build on top of that model. Right, and there is one example, for example, why code LLMs are very important. Typically, if you are working with LLM, it can generate content, like for example, all sorts of conversational content. But unlike normal models, the code generation LLM is able to generate code which can be executed. And while there is still like a lot of work to be done in terms of making this LLM super efficient, but what you can already do is for example, take this example of SQL. It is already possible to use code generation LLMs to generate SQL, which basically automates the execution of queries, which means, for example, you can automate a lot of things, and you can make LLM not only converse with humans, but also execute, access your data. Basically, it's one more powerful use case for LLMs.
Yeah, I just want to jump in here. There was a question that I also want to kind of tie into some of the questions here. There's one of the big questions about open source versus not open source is like, things related to safety, et cetera, customizability. So some of these models are very, very powerful. And there are, of course, more. These are just the main kind of open source models. So why would the large enterprises kind of release them and so forth? I think there are a few different answers, but it might be interesting to kind of hear you kind of mention that. But also, Andrew, I think we should, I know we have still, a lot of content we want to touch. I think we should, try to maybe after this area, maybe move to the next areas.
Sure. Quickly commenting on safety and all. I personally don't believe there's one right answer, which just goes like nails it. Safety can be addressed through proprietary models, but it also can be addressed through open source models. First of all, like Llama, for example, and then Code Llama as well, they are backed by Meta and Microsoft, and they take responsibility about safety and all, and safety in general is a part of their model alignment, which will, if we have enough time, cover to a certain extent. And then by open sourcing the model, you increase the chances that the community will come up and point out where, the safety is not great and it can be improved upon the feedback. Moving on. So here's a slide that gives you some idea how Llama 2 compares to other let's say, proprietary models. This table is a bit old right now, but everything is a bit old right now because, well, new things appear pretty much every day. This particular table comes from the original Llama 2 paper. Basically, it's like 3 months old, but it of course changed to a certain extent. Benchmarks. Benchmarks is a way to tell how models perform and how they compare between each other in different scenarios. So there's lots of benchmarks, and everybody knows that the benchmarks are broken. But for example, MMLU benchmark is probably one of the most known. It's a multitask learning for understanding. This is a very, in my personal view, general benchmark which tests how the model behaves across different tasks. So basically, it's a general benchmark for LLMs. And you can see that Llama 2 actually comes pretty close to GPT 3.5 in terms of the quality, but you can also see that it lags significantly behind the GPT-4. And of course, when people compare Llama to GPT, not probably everyone understands that it's probably wrong to compare these models because the model size is very much different, and not just model size, also architecture of the models. Llama 2, the largest one, is 70 billion parameters. GPT 3.5, 175 billion, basically like almost 4 times larger, and GPT-4 is 10 times larger than GPT 3.5. So you can basically imagine how hard it is to compare them, but the table and benchmarks actually show that Llama 2 is really good, and it comes close to the performance of these extremely large models. There is
a couple of other technical questions we got in the Discord. One question you got is, what types of GPUs do you recommend for fine-tuning, inference, and so forth with open source models? I'm not sure I understood what exactly that means, what type of GPU, because of course it it's just a game that you play with the available GPUs on your cloud vendor or so forth. But I'd love to hear if you have any thoughts about that. The other one is how do you do which transformations do you need to be able to run the inference using these models?
We'll cover that, but for the last one, if you can repeat what is needed for inference?
Well, to get to actually run the inference on it, are there special types of transformations you have to do for these, or they're pretty much all taken the exact same formats?
Got it. We'll cover that, and I really hope if we move fast, we'll cover all of that. So right. I'll do my best to minimize the time we spend on each slide, and I hope because there is a lot of slides and all of them are pretty interesting and very much relevant, and every slide actually answers different type of questions, but all of them quite relevant to the questions I've already heard. So moving on, here's a slide.
We love all your people, yeah.
Yeah, here's this summary of one study made by Snowflake about fine-tuning open source LLMs, in particular Llama and CodeLlama, specializing them for a generation of SQL code. And what this data shows is that even if you fine-tune and using a very small model, like 7 billion, through fine-tuning, you can actually come super close to GPT-4 in terms of accuracy, which is very impressive and very promising. And the most important part here is that it's not just efficient, the fine-tuning, but it's efficient even if you are using very small model, which affects a lot the costs, because hosting Llama to 7 billion parameter model is a lot cheaper than using GPT-4. And this is a great example of using a smaller model and fine-tuning it towards specific tasks. And we'll have another slides about fine-tuning, another interesting one. but for now we can just move on. I'll skip that slide. Maybe just mention that it's the last slide about code generation in this presentation, mentioning two interesting models like Wizard Coder, probably someone heard, and Fint. What makes it interesting is that they've actually surpassed the quality of GPT-4 by fine-tuning Llama 2. The problem there was that, well, it turned out that GPT-4 back then was not that well for generating code, which was fixed, addressed pretty quickly. And as you see on this table now, GPT-4 is still better than any open source model for code generation. But if you go and use these models, and there are a lot of ways of using these models even without serving them yourself, you can see that the quality of this model is pretty amazing. Quick calculator, which gives you an idea how much does it may cost to train open source models or to serve them. So there is a web application by Hugging Face. You can easily find it on Hugging Face, which you can give the name of the model, and it will tell you the amount of memory which is required for serving or for training. So here we have this Llama 2 large model, and we see that well, the column total size tells how much memory we need. And when we say memory, we mean GPU memory. So, well, or other memory, but if you want to keep it fast, probably it's going to be GPU memory. So, for example, without any optimizations for serving Llama 2, the large one, you would need how many? Basically, for A100. 80 gigabytes. It's pretty expensive to use these models without optimization techniques, which we'll talk about. And how do I know how much memory do I need for a model? The rule of thumb here is the following: you just multiply the size of the model by 4, and you give their amount of memory which you need to serve this model without optimization techniques. Means that it's full precision. And if you want to fine-tune this model, like train this model, the rule of thumb is that you would have to multiply it once more, 4 times, and then you'll get the amount of memory you need for fine-tuning these models, which gives you idea how massive it is, even for an open source one. Here's some numbers originally shared by Hugging Face in AWS. If you are serving Llama 2, like what latency and cost you may expect. Again, we are talking about serving Llama 2 large one without any optimizations. So you can see here that what is interesting here is instance type. If you don't know, for example, the last one here, P4D 24x large, it means that it's 8 A100 GPUs, each 80 gigabytes. And you can see here, well, latency, first of all, and you can compare it with what you typically have with GPT-4, which is comparable. And but maybe to note that this data is for one concurrent request. Means that if you have a lot more concurrent requests, a lot more users accessing the LLM concurrently, which probably going to be the case. If you have many users, then latency will degrade and the cost will increase. But if you, for example, say, okay, I want to generate 1 million tokens, here you can see the price, how much it will cost. Right. Later, I'll probably share the slide so everyone can
Yeah,
take
yeah.
these numbers and do some
Actually,
calculations.
Zivy, as we're talking, one of our community managers, Zivy, is taking print screens and putting on the general chat where in the Discord. So you can definitely find it there already now.
Awesome. And I'll also be giving source links for like reference where you can read more about each slide. But now we
Amazing. So
move on.
let's also have you do that on general chat. So wait, just 1 second. I'm going to start off with the first survey before we continue here a bit. So yeah, 1 second. So there are two different. Oh, it's actually both of them together. So there are two different polls that you're supposed to have gotten. Where one of them is asking which model you're using for an LLM app, where it's basically trying to understand, open source versus GPT and so forth. And then the other one, which you got simultaneously, is what would make you adopt LLMs instead of proprietary ones for your LLM-based app. So once the poll is finished, so we have 30% that fill out the first form, that fill out the first poll. Then I think what is it? Yeah, and then no, sorry, 47% fill out the first one, and yeah, I think only when you fill out the first one you get the second one. So I think everyone in the meantime that filled out the first one filled out the second one. So feel free to answer. I'm going to end the poll in a couple of minutes. So Andrew, just keep on after this slide. I'll end the poll and then I'll kind of show and give some insights about it.
Awesome. Yeah. Meanwhile, I'll continue as we've seen in the previous slides. Serving and training LLMs is pretty expensive, and it takes a lot of memory and resources. So one of their important techniques to use is quantization. Well, in a nutshell, what it means is that or maybe another way to say it this way. Typically, weights. Basically, when we're talking about LLM, it's big because there's a high amount of weights to store. Basically, parameters, trained parameters of this model, and typically these weights are stored in a float 32 precision format, and they have high precision, but they require a lot of memory to store, and it's the math calculations for multiplying matrices is pretty expensive operation. So what the quantization technique allows us to transform the weights into a lower precision. For example, instead of float point 32, transform them to float point like 16, or even to int 8 or int 4. This is a super powerful technique because by doing that, pretty much without affecting the quality of the model, you can reduce the size of the model. Basically 4 times for one precision. And we'll see some numbers later, but this makes it a super powerful technique. In the end, what we get is that for both serving and training a model, we need a lot less memory, a lot less energy, and a lot less time for math operations. Basically, the latency is going to be reduced.
Okay, great.
Right.
1 second. Now is a good time to show the results of the polls. Do you all see them or not really?
Don't see them.
You don't see them? Okay, so I'm doing share results over here.
Now I see.
Okay, so now I think you should all be able to see them. So yeah, there are currently currently 74 people are on here. We peaked at 80 something, so maybe 100 something people came in total to this event. Thank you so much all for participating. About the model we're using for the LLM app, so we can see it breaks up pretty nicely. It looks like the numbers here don't really add up, right? Because some folks are definitely using more than one, but it seems that obviously GPT is the most the most common, but open source is not that far behind. Now, there might be selection bias because of the title of the talk, but it's very interesting. Another proprietary model, I've actually been seeing this a lot. I've been seeing a lot of Bard and Anthropic and so forth. But I think something that's interesting is companies that are using Bard or Anthropic are usually pretty serious companies. Like you don't start from that usually. That's what I've been seeing. But I think that's interesting. And yeah, there are a few people that are just here for the food, which I think is corny joke just because it's online. And then for the next one about what would make you adopt open source LLMs, it's really cool with the reasons that Andrey gave before that. It really it distributes pretty well between them, right? If it were cheaper, stability, availability issues, and customizability, privacy, it's really like all those people are around, all those different reasons are like 35-ish, 35 to 40% kind of. So yeah, it's really interesting. It's not like there's one reason to use open source and you just go there. It's just when you start working and you find out there are issues and you look for other ways to fix those issues, and open source is one of the directives for how to do it. No one's doing open source just for fun, or individuals are, but organizations aren't picking open source just for fun. Okay, great.
Yeah, love it.
Okay, great. So I think I'll continue. I think, Andrew, I think we have to raise the pace a teeny bit. I know it's hard because there's a ton of content here, but that's we do want to kind of at least touch a few of the other topics I know we're talking about, and we're kind of wrapping up, I think, already.
Yep. Yeah. So we've just talked about the cost and latency and the quantization technique, and here we can see how quantization technique actually affects the memory requirements. So we can see that if originally you would need like 256 gigabytes of memory for serving Llama 2, if you are using, for example, int 8 precision, it would basically drop to 64, which means that you can actually use just one VM with one GPU A180, for example. Or if you're using int 4, then you would it would be just enough to use one GPU 40 gigabytes, like A140 gigabytes. Same for training. You see that the memory requirement drops drastically. So you'll find this memory calculator yourself from the link and you'll be able to make these calculations yourself. And we are moving on. Here's a slide just to show how quantization affects the cost and latency, which we talked about in the one of the previous slides. You see that here we're using actually quantization, and you see that their total cost for generating 1 million token drops 10 times. And instead of using the most expensive AWS instance, you can use pretty well, I wouldn't say not expensive, but much cheaper instance, right? Another very important technique to know, probably it's not possible to use open source LLMs without knowing this, is low rank adaptation, or short LoRA, which is a fine-tuning technique, and it belongs to their large family of fine-tuning techniques called adapters. And again, it is not easy to explain it in like one sentence, but I'll do my best. What basically this technique does is the following. Again, LLM is super large. In order to fine-tune it, you need to feed it into the memory. So this technique allows you to do, instead of like fitting the entire LLM, we basically introduce an adapted weights, which are much smaller. We also call them trainable weights. And instead of training the whole model, we are only adjusting the small subset of these weights, which represent the things we wanna optimize for. And it can be a lot smaller piece, and it wouldn't require you so much memory, and would be also much faster. And once you fine-tune it using these adapted matrices, then in the end you would merge this frozen weights with those which you've trained the smaller one, and then you'll get a fine-tuned model which will be comparable in the quality. There is a lot of studies, and some people aim for full fine-tuning, but in most cases, at least based on the data which I've seen, it is the LoRA technique is pretty good, and as we'll see in this slide, it reduces the memory and consequently cost requirements significantly. Here is an example of the Falcon, the largest one, and you can see how the memory requirements changes if we are doing full fine-tuning, like 5 terabytes, or using LoRA. Basically, it's like almost 5 times lower the requirements for the memory. But then if we are combining quantization and LoRA together, this drops like drastically. This is the way you would probably train these models if you aim for relative like quality without overspending. So this is a super powerful technique. Right. Here's a study which proves this. This one is by Anyscale that shows how this works for different kind of tasks. So they came up with 3 different problems. One is extracting structural data from unstructured data. Another one is generating SQL code. And the last one is solving math problems. And you see how if like accuracy compares for different size of the models and for different fine-tuning techniques. And the most important message here is that LoRA technique is super effective, even if you are using a smaller model. And if you are fine-tuning a smaller model using the LoRA technique for a very specific task, it not just matches the performance of GPT-4, but it surpasses by great margin the quality of GPT-4. And this is probably should be the main message for this talk, why you should take open source LLM seriously, because they can beat GPT-4 across a lot of tasks and give you not just privacy and customization, but also a lot of cost saving here.
Okay,
last one here.
Yeah, there are a couple of questions you've been getting about the combination between quantization and accuracy. So just to make clear, I know it's clear probably from this slide, but just to say, everywhere when people talk about quantization, they're always looking both at performance and at like both at the accuracy and at the like IT performance, right? That you never just like forget about performance. Whatever you're measuring and checking with the baseline. Sometimes it's not presented well enough, right? Where that accuracy wasn't damaged that well, but usually it's done, right? Like we don't, like that's almost always the case. So you're making sure about, there was a question here about exploding gradients and so forth, right? Just making sure, from your experience, it's always done side by side, right? And there's always a trade-off, but in a lot of cases, you can do quantization without killing the performance that much.
Yeah, in the end, you test it and you know if it works or not. But yeah, a large body of experiments actually show that it works pretty well. And it should be the first thing on your list, like to try before you can, for example, use the full fine-tuning or change your mind about which precision you want to use.
Amazing.
Don't be afraid. This is a complicated slide, but the original idea for this was to explain how ChatGPT works, even though it doesn't address it to like completely. But what is important here? We are talking here about 2 techniques, SFT and which stands for supervised fine-tuning, and RLHF, which stands for reinforcement learning human feedback. So how does it work? And this partly answers to the question why ChatGPT is so great. We typically start by pre-training a model. You've heard that term probably, like a pre-trained model, and how a pre-trained model compares to a trained model? Here's the answer. I'm shortening it. Typically, you take a lot of data, low quality, or another way to say that would be you take the internet, some snapshot of the internet, and you feed it to your model, and then you get a pre-trained model. Means that it is trained, but on a content of data low quality. It has all of sorts of biases and mistakes, but it's pretty fluent. And it's not enough because this model only can complete prompts, basically generate text, but it cannot answer questions or follow instructions. So in order to address this, you typically need to do SFT, which requires you taking high quality data, not just unsorted data, but data that is curated by humans in a right way. And by using this SFT technique, you train another model, which now can follow certain let's say expectation, which can match certain expectations. You can teach a model to follow instructions. For example, when we're talking about chat model, it's a model trained this way. It can follow the dialogues and all of that. And for that, you would need this called demonstration data. But it doesn't end there because it has some level of education, but it's not that great at it. So here comes another method, which is called RLHF, human feedback, where you do the following. You prepare
Andrew, just a time note. Let's aim for 5 more minutes, so that will include like 1 or 2 questions, and then let's. There are always a million more issues to discuss, and feel free to also ask any questions in the general chat. I'm sure Andrew will have a look afterwards, and also anything we didn't touch in depth, then we can also kind of share there.
Yep. It's one of their last slides, so I'm finishing it quickly. These techniques work the way that you would have to prepare curated data that shows which answers are good and which answers are not good, and you prepare that in a scalar form. Basically, you rate every label, every response, with a scalar from 0 to 1, how great it is. And then using this data, you train another model, which is called reward model. And then you use this reward model to train your pre-trained model. And it works exceptionally well. And basically you come close to a lot better quality by this way. In the reference, you'll find quite a few links where you'll be able to read about it. But we move on. Here's a list of some of the frameworks which I'd like to mention. Especially for those who are interested in trying open source LLMs. And by no means it's complete list. There are so many libraries and frameworks and all, but I would just mention this, especially if you are about to adopt open source LLMs. First one on this list is text generation inference. It's a toolkit by Hugging Face, which is offered in a form of Docker image, and you can give it a name of their LLM from the Hugging Face repository and add some configurations, and you can serve this LLM using this Docker image pretty flexibly in any place. So this is the most convenient way of serving, I would say, LLMs in any environment. It supports all kind of optimizations. Well, most importantly, it supports quantization and flash attention. So it's a pretty good way. There are some like nuances about the license, but as long as you are not planning to provide LLMs as a service, you can use this without any worries. Second one is called PEFT, parameter efficient fine tuning. This is something that you would use if you want to use LoRA or quantized LoRA. It's again library by Hugging Face, pretty flexible, convenient, and you can find a lot of tutorials and examples how to use that for fine-tuning llama or a similar model. Then I would mention TRL, which is Transformer Reinforcement Learning, which allows you to use this SFT and RLFHF techniques, again from Hugging Face. The only one which is not from Hugging Face here on this list is DeepSpeed, if I'm not mistaken, from Microsoft. This is a powerful library that optimizes training, especially if you are using multiple nodes, basically doing distributed training, and it optimizes the memory use. That's probably it. The last slide, a few words about Dstack. And I'm one of their core developers on the team as well. For Dstack, Dstack is an open source library which allows you to train or fine-tune LLMs using any cloud provider. So it's basically cloud agnostic toolkit for training and serving. But what is also great is it doesn't bound you to one particular framework. You can use pretty much any other libraries. For example, text generation inference, fine. PFT, fine. So you decide it's super flexible. You can basically use any other frameworks together with Dstack. Yeah, probably we are on time, or maybe surpass time just a bit. But Philip, do we have time for any questions?
Yeah, so I mean, I think we took a lot of the questions as we went. Maybe let's do one last question. So there was a question as for the last part, how would you compare the performance of DPO with PPO?
Just want to be straightforward. I'm not an expert in this topic, and you would probably need a lot of time doing engineering and comparing them. I wouldn't really comment on that, but we can also follow up on this in a chat.
Yeah, I think for that, because it's in the Discord, you can just comment on offline and so forth. So I just want to say, when Andrey and I had like a prep call before this, we talked about who the audience is and so forth, and I said I think this is a talk that it's not that interesting for people that are just getting started. Like I'm sure it's interesting intellectually, but a lot of people are getting started just right away, start using GPT 3.5, GPT 4, and companies or teams that are looking at open source, it's usually their second iteration or a bit later. So we kind of realized that we want mid-level and senior people to also get value out of this. I think there was a lot of interesting information here from a lot of different areas. And for me, I learned a lot. I've already, met quite a lot of teams and kind of, had some internal hands-on work when I have the time in these spaces. And I learned a lot from it, a lot of considerations. I think my main takeaway is, okay, fine-tuning to save costs or to save memory or to save resources and not to be like better at quality. That seemed to me like a big thing that I didn't really realize how strong a case there is before the event. But I think there are a million different takeaways, and just seeing all these different tables and graphs at once, I think kind of enables you kind of in one flow to see what's more important, less important to look at. So I know there are different takeaways. If you have anything specific, either questions or just takeaways you had, you know where to find us on Discord. So both Andrey and myself are on the Discord. And again, future events, future speakers, and so forth, reach out, and see you next time. So yeah, next event with Qdrin, again, in something like 10 days. Sign up. I sent the link, but hope to see you there, and great to meet you in the meantime. Thank you so much.
Thank you, Philip, and thanks everyone. Yeah.
I'll be in touch.